All right, here's our last proof for this section. We're gonna prove some stuff. One thing, prove that MO is congruent to PO with this given information. All right, so we're given circle O. Here's O is in the center, that's why we call this circle O again. We're also given the angle T is, now this comp, that word, what does that actually mean? That stands for complementary. Do you guys remember what complementary means? So angle T is complementary to angle MOT. Complementary means that they add up to 90 degrees. Angle S down here is complementary to angle POS. All right, now with that information, prove that MO is congruent to PO. So we've got some things filled in already, and we have to come up with all the reasons this time. So first statement is circle O exists. How did we know that circle O exists? You guys already writing in the word given? Good. All right, we also know angle T is complementary to angle MOT. Again, that was given to us. Angle S is complementary to angle POS, given. All right, now this next one, this is something we can come up with on our own. It says that OS is congruent to OT. So let's go ahead and fill in that mark that congruency. OS is congruent to OT. How did we know that though? That goes back to the radii of a circle. All radii are congruent. See how nice circles are? Okay. So, what else can we say about our circle? I mean, not about a circle. We're basically, again, our goal is if we can prove that these two triangles within the circle are congruent, then we can use CP/CTC to say that any of the corresponding parts are congruent, which is what we're trying to prove in the end. So, I see that we've got two intersecting lines right here at the center of the circle. Intersecting lines give you vertical angles, and vertical angles are congruent. So we can go ahead and say, I marked it up in the picture, that those two angles are congruent. Angle MOT is congruent. You guys might already have this written in, I'm not sure. Angle POS. And how do we know? Vertical angles are congruent. All right, now we can use all this complementary stuff. How does that help us out? Well, our complementary angle theorem tells us that these two angles will be congruent to each other. Oh, I accidentally erased. All right, the two angles at O are vertical, so those are congruent. Then we've got, I'm going to give two curves on those. Because the two angles at O are congruent, these vertical angles, and they told us that these are complementary, means they add up to 90, and these two add up to 90. So you guys looking up at this figure with me? So if angle O in this triangle adds up to 90 with S, and angle O in this triangle adds up to 90 with S, and O, the two angle O's are congruent, that means that the other two angles will be congruent also. So we're going to say that angle T is congruent to angle S, and that's our complementary angle theorem. Or complementary angles are congruent theorem. All right, so if you look at your triangle, it looks like we've got two angles and an included side in each triangle as congruent. So that's going to be your angle side angle. So right now we have enough information to say that our triangles are congruent. So triangle TOM is congruent to triangle POS. And how did we know? Angle, side, angle. Now that you have congruent triangles, you can say that any of the three sides or any of the three angles are congruent. So we can say that MO is congruent to PO, and how do we know? Because corresponding parts of congruent triangles are congruent. Done.